Good morning all. In this session, we will study continuous distributions which are used to model quantities that can take infinitely many values within a range. Unlike discrete distributions, continuous variables are not countable and can take any value within an interval. So example includes time, distance, temperature, etc. So in this presentation, we will understand the concept of continuous distributions, their types, and solve problems based on uniform distribution. A continuous distribution is defined over a range of values that are infinite and uncountable. This means that variable can take any value within a given interval. For example, time can be measured in seconds, milliseconds, or even smaller units, and it continues infinitely. Because of this, probabilities are defined over intervals rather than at single points. There are several types of continuous distributions. So in this course, we focus mainly on three types: uniform distribution, exponential distribution, normal distribution. Each of these distributions is used to model different real-life situations depending on the nature of the data and the problem. So the moment generating function of the uniform distribution is given by mx of t equal to minus infinity to plus infinity e power tx into f of x dx, where f of x is given by 1 by b minus a. A and B values limits between the values of x. The uniform distribution is one of the simplest continuous distributions. So in this distribution, all values within a given interval are equally likely. This means there is no preference for any particular value. The graph of a uniform distribution is a horizontal line over the interval indicating constant probability density. So the mean and variance of the uniform distribution is given by mu is equal to integral over a to b x power r into f of x dx, where f of x is the probability density function of the random variable x and is given by b plus a divided by 2, and the variance given by b minus a the whole square divided by 12. So in uniform distribution, the probability density function is a constant over the interval. If the interval is from a to b, then the probability density function is the same for the every value between a and b. The total area under the curve is equal to 1, which represents the total probability. The moment generating function of the uniform distribution is used to calculate important statistical measures such as the mean and variance, which is derived from the probability density function and provides a mathematical tool for analysis. So using this, we can find the moments by differentiation. So before solving the problems, it is important to understand that the probabilities in continuous distributions are always calculated over intervals. The probability at a single point is 0. Therefore, we focus on ranges and use integration or formulas derived from the probability density function. Let us go inside the problem. The first one is on subway train waiting time. So in this problem, a subway train arrives every 30 minutes and a person arrives at a random time. We are asked to find the probability that the waiting time is at least 20 minutes. Since the arrival time is random, the waiting time is uniformly distributed between 0 and 30 minutes. So let x represent the waiting time. Since x follows a uniform distribution over the interval 0 to 30, we calculate the probability that x is greater than or equal to 20. So this is done by finding the ratio of the favorable interval to the total interval length. So this gives the required probability. So the value is for the value that he has to wait at least 20 minutes is given by 1 by 3. The next problem is on bus arrival. So in this problem, buses arrive at every 15 minutes and a passenger arrives randomly between 7 and 7:30. We need to find two probabilities. The probability that the waiting time is less than 5 minutes and the probability that is more than 10 minutes. So to find the probability, that is, first we will be finding f of x as 1 by b minus e, that is 1 by 30 minutes. To find the probability that the waiting time is less than 5 minutes, we consider the interval where the waiting time is between 0 and 5. Since the distribution distribution is uniform, the probability is simply the length of its interval divided by the total interval, which is 30 minutes. So which is 1/3. Similarly, to find the probability that the waiting time is more than 10 minutes, we consider the interval from 10 to 30 minutes. Again, we divide this interval length by the total interval to get the probability. So this shows how uniform distribution simplifies the calculations. This slide introduces another problem related to continuous distributions. The same principle applies. Identify the distribution, determine the interval, and calculate probability using the ratio of the length. The solution follows the same steps. Define the random variable, identify what kind of distribution it is, and compute the probability using the appropriate formula. Consistency in approach is the key to solve these problems correctly. So the values for all is given here. This slide presents another example problem to strengthen understanding. So practicing multiple problems helps in mastering the concept of uniform distribution and continuous probability. So here the value of x of 200 to 250 is given. So as like the previous problems, we will be finding the probability density function and we will be calculating the probability of x which is greater than 230. So the same as like the previous problems. So there a real life scenario is given and we are asked to find out the answer. So here it is not about the scenario, about the conceptual understanding to find the mean, median and the standard deviation. So each problem reinforces the idea that in continuous distributions, probabilities depend on intervals rather than the individual values. So the solution demonstrates the same methodology. By consistently applying this concept, we can solve any uniform distribution problem effectively. So to summarize, continuous distributions deal with variables that can take infinitely many values. The uniform distribution is the simplest among them, where all the values are equally likely. Probabilities are calculated over the intervals using the simpler ratios. So in conclusion, continuous distributions are essential in probability theory. So understanding uniform distribution provides a strong foundation for learning more advanced distributions like exponential and normal distributions, which should be seen in the upcoming classes. So mastering these concepts is important for real world applications and further studies. Thank you.